excited to be here and talk with you for a few minutes today. My format is going to be that I will go through and talk about some of the technologies that I myself have been involved with, and then just some other cool pieces of technology that I think are interesting and fun, up and coming. I believe my job here today is to get you guys excited about technology. When you think of startups for entrepreneurs, 90% of it is what? Tech startup, right? So I want to go through and show you some of the things that I've been involved with. Technology is many things. Sometimes when people think of technology, they think software. It's not just software. It's cool gizmos, but it can be applied in a lot of different manners, okay? And it can also be applied in just about anything that you do. So I took this picture. It's actually, I think, from Terminator or something. I don't know what. But not only is it robotics, but CGI and the technology involved with movies. I grew up in the days of Star Trek, the initial Star Trek. You look at that now and it's really hokey, right? Because of technology, CGI, and different things that have been developed. Consumer electronics, your phone. You used to use Pony Express to talk to people that were not very far, that were far away. Now you can sit, you have your smartphone, you text, you're emailing, surfing the web, everything, all because of cool technology inventions. Cars, tons of technology involved with cars. Sporting equipment and recreational activities all have new technologies which help them do cool things. Robotics, as far as for amputees, and a lot of medical device equipment. Computers, different parts necessary for it, and certainly space and aerospace activities. So broaden your mind as to whatever you have passion about, realize that technology can be involved with it. In fact, the National Science Foundation has come out with a report that says by 2020, 70% of all jobs are going to require science, technology, engineering, or math. That's a lot, okay? So let's go through and talk about some of these things. The first thing I'm going to talk about is some of the work I did at BYU, and then that transferred to Boeing. Here I have two carbon composite tubes, all right? These carbon composite tubes are made out of carbon graphite, and I want you to listen. They're about the same thickness, same dimension. This one weighs just a hair bit more. Listen to the difference. Big difference, okay? What I was able to develop for my PhD was the use of how you specifically design with composite material to reduce the vibration, reduce the frequency, reduce the sound. So this one has a very high pitch. It vibrates a lot, thus you have a very high pitched, loud sound. This one, not a lot of vibration. Where could you use that? Could you use that in anything? Yeah. Maybe something with the plane. Okay, I'm giving you one hint here. Right, but there's a lot of areas that you can use a principle like this. Okay, so we'll go first over the one that's up on the board. This is a C7. The C7 have an issue behind the wings where wind comes off of it. As the wind comes off of it, it vibrates the structure. As it vibrates the structure, that's a bad thing. You actually create cracks, and cracks are really bad. Yeah, 40,000 feet, you don't want a crack, right? Here's the cool thing actually about a C7 though. You can actually have a 48-inch gapping hole and it'll still fly okay. But that's just side note. We went and installed specific and cool sensors and monitored and measured what that vibration was and how it was happening. An engineer then went and designed a patch. Now this patch was a cool patch This patch did two things. Number one, you had a crack, so you needed to cover that up. So there was that's termed a structural repair, all right? The second part of it was actually using this technology, which is called a dampening section. By applying those two mechanisms and designing it specifically and installing that patch, this airplane could then go and fly. Not only was the crack fixed, but additional cracking was prevented. So in fact, what they would do is they would take this repair without the structural aspect of it and stick it on all the aircraft so that it didn't ever have cracking occur. Okay? So kind of a cool and unique option. One of the other activities I worked on was ASIMS, Autonomous Structural Integrity Monitoring System. Lots of terminology there. Basically, the idea is this, is aircraft, again, you don't want cracks. You also don't want corrosion. There was a big incident in 1980 called the Aloha incident, where an Aloha aircraft was flying and the bolts along the front fuselage, actually all of them unzipped like a zipper. Flew off, and sadly some people seriously injured and someone died because they weren't, the flight attendant wasn't seat belted in and flew out. So it's dangerous. It's a bad thing to have corrosion on an aircraft. A way to monitor that is by putting sensors. So we went through, developed sensors. I'm going to talk about these sensors because there's some cool technology with the sensors. Had a small data acquisition box. This box was the size of about 2 decks of cards. Put these sensors down in key locations. Then we worked with this corrosion prognostic algorithm. So even math can have cool technology. This math is really cool. It was actually developed by Australians. They took neural network behavior that they had discovered from beehives and applied that to math, and then could apply it to corrosion rates. So thus, you monitor in a few key locations corrosion, temperature, pressure, relative humidity, moisture, and strain activities. You can then apply it to all parts of the aircraft to make sure that your aircraft are safe. Now, here's what the sensors, that's what the sensors look like. This was probably 3 inches by an 1/8 inch diameter to give you a reference for how big that was. This right here is what the sensors were by the time I left. This is fiber optic. So think about the size of your hair. Think of about 2-pound test line, but not nearly as rugged fishing line if you're a fisher person. Inside here, actually, there is temperature, pressure, measurement capability. How cool is that? That's pretty cool, isn't it? Okay? And it's getting smaller and smaller. So just to get you thinking about some things. I also work for BD Medical. How many of you have had an IV inserted? Yeah, just about everybody. And by the way, average is that everybody will have some IV inserted into you at some point in time. IVs are not fun. They used to be a lot worse. They used to use metal, Teflon, to stick into you. The problem with that is while it can handle the body, our bodies are actually very caustic. Okay? Teflon was a problem in that it would damage your blood vessels. So you'd get what they term phlebitis. The other issues you needed to handle with is caustic exposures. A lot of times when IVs and catheters are put in, for example, for cancer patients, they're putting in some really caustic and nasty medicine to help people. But you're having to pull those in and out all the time because basically the catheter gets eaten. Thus they used Teflon initially. BD Medical came up with a new material called Vylon. Vylon is really cool. I have a sample of what. Vylon is really cool material in that it is pliable. So as you insert it into the bloodstream, after 30 minutes it actually softens, which makes sure you don't damage your blood vessels so much. At the same time, it's this really cool and unique polymer that your body won't attack it, but it can handle a lot more of those caustic medicines that are put in. Now, the other unique factor about Vilon is when they thread IVs through your body, a lot of times they'll thread it through for cardiac application. They have to be able to see that with X-ray. You can't do that with a lot of plastics. You can't see. It has to have some metal component to it or additive. Vilon has that in it so that we can see it. Very cool pieces of technology. Since we're talking about medical devices, we talked about miniaturization. How many of you have heard of buckyballs or fullerenes? A couple? Okay. That's nanotechnology. They're small carbon atoms put together molecules with 60 carbon. Okay. With that, they're really tiny, 1 nanometer. That's really, really small. 1 times 10 to the minus 9th meters. Right? It's hard to even comprehend because you can't see it. Currently, cardiac ablation, or just recently, cardiac ablation required that they basically cut the sternum, pull apart in order to do the ablation activity. That was significant issues. Take a long time to recover from that. They now can use instrumentation where they thread it up through the IV, through a catheter system, into the heart area to perform laser surgery. With that laser, however, it becomes very hot, and they actually have a temperature measurement system that they place on the outside of your chest to be able to determine. But with the laser, it gets hot. You have mass between where they're performing the activity and where they're measuring, so the temperature isn't quite right. As a result, it might get a little bit hot, more scar tissue. They also have to thread multiple pieces of equipment through so that they can see, so that they can perform the surgery and take all these measurements. It still takes a significant time to heal from one of these procedures, but it's getting better. With nanomaterial technologies, they're looking at very soon, and this is actually up at Utah State, is having a single catheter that can do temperature, blood flows, types of cells, all of this activity in one single piece of instrument. And because they can know temperature at the exact location, they can reduce the scar tissue, and as a result, no heparin could be used as well. Cool technology. Let's stay on the medical device world. Cancer treatment. Varian Medical System performs a lot of work with cancer treatment. I've worked with Varian. With that, right now, they target a specific location. Let's say you have liver cancer. They go in and they target a specific area where you have cancer and kill everything in that area. Very destructive to the body, very tough on the body. With nanomaterials, they now have the ability to have nanomaterials which have special stuff, additives put inside them that are attracted to only cancer cells. Thus, they put it in your body, it attracts to the cancer cells, then they use special lights to be able to do phototherapy. And they can concentrate and kill only the cancer cells that are affected instead of the entire region. How much better would that be for people to be able to heal and improve, to be able to target specific cells rather than locations? All because of technology. Bendable glass. I have a friend that works at Corning, and with that, they're coming up with really cool technology. At first I was like, okay, bent glass. Yeah, we have bent glass, right? Our windshields in our cars are bent. That's not very cool. And he said, no. It's glass that actually bends in use. And I'm like, okay, that's really cool. It's completely flexible once made. So you could roll it, you could take your glass and roll it up. You could do things like a watch. Remember, oh, actually maybe nobody does. They used to have a swatch, right, that you could flip on your wrist, and it was bent. They're looking at doing that now with glass. Now imagine you have your LCD, you can have electronics input into it. You don't have to have a smartphone, you have a smart watch. Use your imagination, because things that you don't think are possible eventually, somehow, some way. Really neat stuff. This also allows us to have high-quality electronics with continuous processes and learnings as secondary processes. Just really neat things. Let's talk about sustainability. Obviously, we want to take care of the earth. We, especially as Americans, are resource hogs. I'll admit it, I'm one of them. What can we do to improve that? Well, right now, solar energy, you can put big panels up, right? If you go to California and Arizona, they have great big solar panels put up on their rooftops. And I know myself, especially this last week, I have a yard. I like my grass. It rained a lot, so I have to mow it, which I don't care for the mowing, but I do like having a lot of grass around. There's a company in Florida that's actually developing an AstroTurf that's made out of some cool polymer material that will absorb and act as the solar panel system. So now you have an artificial turf, which you don't have to mow, you don't have to water, so you're saving on a lot of natural resources that way, but you're actually also gathering the light to create solar energy. That's pretty amazing stuff. Not only is there some polymer materials, but there's also, it's termed a high conductivity transparent electrodes, all right? And that's what's used to help with gathering of that solar energy. So sometimes it's a combination of multiple new technologies put together to create an even cooler product. And I think this is important as I'm thinking about this, just as a side note. One of the important aspects is to look at other industries and what can you take from those other industries and apply for what you're looking at. For example, this carbon composite material, I actually went and researched weaving. I went to some rug manufacturing and fabric manufacturing companies to learn how to take the carbon fibers and actually weave it in the appropriate orientation to be able to automate the procedure for making these sorts of pieces of equipment. So sometimes look elsewhere for your solutions as well. 3D printing. 3D printing is a new and cool technology. I started in college hearing about rapid prototyping, which they'd have this huge big piece of paper, and it was basically cutting paper and gluing together to stack up to create these rudimentary parts. Now 3D printing uses, this is the size of a typical PC computer box. You stick that in there and you can have as big of that as you want, and you can create really cool and intricate parts. In fact, Shauna and I were both at a presentation last week about this, that, wow, they do cool things. They can create an amputee hand. It was, instead of $50,000, it was like $1,000 to create it for a growing child. Amazing. These objects, they can now create that actually work. So for example, you throw in a wrench, it can go through, duplicate it, and replicate a working wrench, even with all the parts moving. One of the big applications that I've seen this in is that they want to use this in the space shuttle. Tools are expensive and important to have up in space, but you don't want to carry a lot of extras because it costs about $20,000 for every pound that goes into space on a conservative basis. Being able to have a system and machine that you could then, if you lose something, say, hey, send me up the drawings. You get the drawings and you can make a part right there. Pretty amazing. As you guys come up with really neat and cool ideas, you now have a very cost-effective way to create a prototype. Much more so than previously. and I'm just going to hit one more. I got a minute. I love sports. I played volleyball in college. I love going to watch sports, and so I wanted to bring up a couple ideas again, talking about, remember, anything that you have passion in can involve technology and cool ideas. This I took from the 2010 Olympics. First thing is a top steel. There was a guy that had invented some cool technology. He actually went to where he was from, and they said, no, we're not interested. So he said, well, I'm going to go help USA out. So he came over to the US, immigrated, and developed this transformational induced plasticity. Now, what does that mean? This is what it means, all right? The blade changes as it's going down the ice. As it goes faster and faster, the molecular parts of the blade change to help it go faster. How cool? Now, it costs $20,000. This is not a cheap sport anymore. But how cool is that? That's, wow. The starter's pistol, right? You're in high school, the starter pistol, it looks like a gun, it is a gun, it goes off. After September 11th, they started having issues taking those starter guns through airport security. The other interesting fact is the speed of sound is much different than the speed of light, in that the speed of sound is not only slower, but it also is affected by relative humidity. How humid is it? Where are you located at? So somebody went through and invented a gun, which doesn't look like a gun so much anymore, and also uses the speed of light, which is a constant no matter where you're at. And it travels much faster, so there's a much quicker response time. So I wanted to show you a few things here, but know that technology, again, it's in everything, in everywhere, and think about the endless possibilities that you guys can do by coming up with new ideas. So, thank you.